On certain nights each year, the sky puts on a spectacular show. Streaks of light flash across the darkness, brief and brilliant. A cosmic fireworks display known as a meteoroid shower. For centuries, these celestial events have fascinated stargazers, inspired mythologies, and sparked scientific curiosity. But behind their fleeting beauty lies a story of ancient space rocks, icy comets, and planetary orbits. Meteoroid showers are more than just pretty lights. They're physical evidence of how our solar system formed, evolved, and continues to change. This episode unpacks the science behind these mesmerizing events. What causes meteoroid showers? Where do the space particles come from? Why do they arrive like clockwork each year? To understand meteoroid showers, we must journey across space and time, from the cold reaches of the outer solar system to Earth's upper atmosphere, tracing the cosmic debris that becomes one of the most beloved phenomena in the night sky. Before we explore meteoroid showers, let's define the key terms. A meteoroid is a small rock or metallic particle in space, usually no larger than a boulder, but often just grains of sand or dust. When one of these particles enters Earth's atmosphere and burns up due to friction, it creates a streak of light known as a meteor. If a larger chunk survives the fiery descent and reaches the ground, we call it a meteorite. A meteoroid shower, then, occurs when Earth passes through a cloud of these particles, often the trail left behind by a comet. As dozens or even hundreds of meteoroids plunge into our atmosphere each hour, they create a dazzling display of meteors appearing to radiate from a single point in the sky. But this isn't random. Each shower follows a pattern, and each has a fascinating origin. The primary source of meteoroid showers is comets, icy, dusty bodies that orbit the sun in long, elliptical paths. As a comet approaches the inner solar system, the sun heats it up, causing its ices to vaporize and release gas and dust. This creates the familiar coma and tail, and more importantly, leaves a trail of debris along the comet's orbital path. These particles, some as tiny as sand grains, remain in orbit long after the comet has passed. Over time, the debris forms a ring or stream of meteoroids circling the sun. When Earth's orbit intersects one of these debris streams, we encounter a spike in atmospheric meteoroids. This is when a meteoroid shower occurs. Each shower is linked to a specific parent comet. For example, the Perseid meteor shower comes from Comet Swift-Tuttle. The Leonids originate from Comet Tempel-Tuttle. The Geminids, interestingly, come from an asteroid, 3,200 Phaeton, making them a rare exception. As Earth plows through the debris stream, each particle enters the atmosphere at tens of kilometers per second, fast enough to superheat the air and cause the glow we see as a meteor. It's important to distinguish a meteor shower from a sporadic meteor. On any given night, it's possible to see random meteors, individual meteoroids that hit Earth from scattered directions. These aren't part of a specific stream and occur unpredictably, though they're more common after midnight due to Earth's rotation facing into the orbital path. Meteor showers, on the other hand, are highly organized. They appear to radiate from a fixed point in the sky called the radiant, which is usually named after the constellation in which it lies. For example, meteors from the Perseids appear to radiate from Perseus, while those from the Leonids originate near Leo. This apparent convergence is an illusion of perspective. The meteoroids in a stream are moving along parallel paths, but from our vantage point on Earth, they seem to fan out from a single spot, much like train tracks that appear to merge at the horizon. Meteoroid showers happen at predictable times each year, as Earth crosses the same debris streams in its orbit. The best time to view a meteoroid shower is usually after midnight, when your location on Earth is facing into the stream. A dark, moonless sky away from city lights is ideal, and no telescope is required. Just your eyes, some patience, and perhaps a warm blanket. What we see as a meteor, that glowing trail across the sky, is not the meteoroid itself, but the ionized gas and heated air around it. As the meteoroid rips through the upper atmosphere at speeds up to 72 kilometers per second, it compresses the air in front of it, causing intense heat. The meteoroid quickly vaporizes, and the energy released excites atoms in the surrounding air, causing them to emit light, the familiar flash we see from the ground. This glowing trail usually lasts just a second or two. In rare cases, a meteor may be unusually bright, known as a fireball or bolide, and may even produce audible booms. These dramatic events are caused by larger meteoroids, often pebble or rock-sized, and can sometimes result in meteorites. Modern science uses radar, optical cameras, and even satellites to study these events in real time, learning about their composition, speed, and trajectory. While they may look like shooting stars, meteors are actually time capsules from the early solar system. Most meteoroids are over 4.5 billion years old, formed during the chaotic birth of our planetary neighborhood. Their composition, often silicates, metals, or carbonaceous material, reveals details about the early building blocks of planets and moons. By analyzing meteorites recovered on Earth, scientists can study isotopic ratios, mineralogy, and even organic compounds, clues about the chemistry that existed long before Earth had life. Meteoroid showers, then, are not just visual wonders. They're opportunities to study ancient material entering our atmosphere. They allow astronomers to model debris streams, track the orbits of comets and asteroids, and even predict future impacts. While most meteoroids are harmless, burning up harmlessly high above Earth, a few have a more dramatic fate. Large meteoroids can survive their descent and impact the ground, causing real damage. One of the most famous modern examples is the Chelyabinsk event in 2013, when a 20-meter-wide meteoroid exploded over Russia with the energy of 30 Hiroshima bombs. Though it didn't cause fatalities, it shattered windows across a wide area and served as a wake-up call to the risks of near-Earth objects. Fortunately, meteoroid showers are composed of much smaller particles. Still, they remind us that Earth is not isolated from cosmic events. We are constantly interacting with our celestial surroundings. Across time and cultures, meteoroid showers have inspired awe and storytelling. Ancient peoples saw them as messages from the gods, omens of change, or even the souls of ancestors falling from the heavens. In modern times, they continue to capture our imagination as symbols of wonder, as scientific tools, and as reminders of how dynamic and interconnected our solar system truly is. Whether you're a professional astronomer or a casual stargazer, there's something deeply moving about watching meteors blaze across the sky, knowing that you're witnessing material from another world, burning brightly for just a moment before vanishing forever. Meteoroid showers are far more than simple sky shows. They are the visible footprints of comets and asteroids, the story of ancient particles meeting Earth's atmosphere in a blaze of light. They connect us to the larger processes of the cosmos, to the icy wanderers that shed trails of dust across the solar system, to the physical laws that guide their descent, and to the history of our planet's own formation. So next time you lie back under a clear night sky during a meteor shower, remember, you're not just watching falling stars. You're watching the Earth move through a trail left by a long-lost comet, lighting up the sky with whispers from billions of years ago. It's science in motion, a cosmic story written in streaks of light.